Hola, mi clase. All right, we're doing 4.4. We are going to distinguish between proportional and non-proportional situations. So may not be story problem. May not be just graphs. They're going to be story problems. So just as a reminder, proportional relationships are between two quantities in which the ratio of one quantity to the other quantity is constant. It's in this form of the equation, right? The one that doesn't have plus or minus. So y equals kx, or now, since we know that k basically means m, y equals mx. The non-proportional ones are still linear, but they're written with y equals mx plus b, where it could be plus or minus. B can't be 0, right? Because if it's 0, then it's proportional. It's a straight line, but it does not go through the origin. All right, so first one, the number of years since Keith graduated from middle school can be represented by the equation y equals a minus 14, where y is the number of years and a is his age. In the relationship between the number of years since Keith graduated and his age proportional or non-proportional. So we're trying to see, is it in the form y equals mx, or is it in the form y equals mx plus b? Well, because there's this added piece, which we can write as plus negative 14, it is in this boat, which makes it non-proportional. It's all because of this right here. That's it. That's all we have to do. All right, so as long as you can explain that, hey, because it says minus 14, it's non-proportional, you're good to go. So then we have tables. So that was the story problem. Now we have a table. We need to determine if the linear relationship represented by each table is proportional or not. So remember, when it comes to tables, we don't even have to look at the equation. We can just look at the ratios. So if I compare 30 to 2, I get 15. And if I compare 90 to 8, right, we want to see if that's 15, and if it's not, then it's not going to be proportional, but if it is, we need to keep going. So 90 compared to 8, right, 90 divided by 8, that's kind of what I'm doing. It's not going to be 15, okay, so either we can reduce it, or we can just figure out what it is, and when I divide this, it's 11 and 2500, so this would be non-proportional. All right, so let's compare here. So we're going to compare y's to x's. Well, the first one's 1 over 5. Can't reduce that. The next one's 8 over 40. Well, if we reduce that, we do actually get 1 over 5. And then the last one is 13 compared to 65. And the reason we have to compare this one is because these two are equal. Well, when I reduce this, it actually is 1/5 as well. So we would say this is proportional. So when the ratios are not equal, non-proportional. When they're equal, proportional. All right, let's see if you can do number 1 and 2. Right, we've talked about graphs a lot. You have the definition of the graph, so if you need to, go look there at our key terms. So is number 1 proportional or non-proportional? Is number 2 proportional or non-proportional? So hopefully for the first one, you said non-proportional, because right here, it does not go through the origin. And hopefully on the second one, you did say proportional, because it does go through the origin. All right, so the last 4 questions are wanting you just to look at the equations and to determine if they're proportional or not. Remember, we're looking for the 2. This one's going to be y equals mx, and this one will be y equals mx plus b. That's what we're looking for. So maybe pause here, try to answer. If you want, you can just put n and p, right? Non-proportional for n and p for proportional for right now. And then you can push unpause and see how you did. All right, so the first one, we should have said it was proportional. That's because there is no plus or minus, right? There's nothing here. This one's non-proportional. And that's because of this right here. This one is also non-proportional. And it's actually because of this right here. And this one it doesn't even have two variables. I think there's a variable missing. But this doesn't even have two variables. We don't know what it's going to be. Excuse me. So that's going to cause a problem. So we would actually also call this one non-proportional because we don't have our two variables. So that one was a little bit of a trick question, right? So non-proportional because it doesn't fit the term of proportional. And so it's got to be non-proportional. All right, so things to remember. Okay, so proportional are going to be equal ratios. Whoa. Straight line through the origin. And then non-proportional, totally spelled that wrong. Not this stuff. I like that. All right, here's your independent practice. So just let me know if these are, actually don't even worry about compare and contrast. Just tell me, are these proportional or not? Proportional or not. That's all I want you to tell me, and then be able to tell me why when we get back to class. All right, until next time, adios.